So when we're looking at triangles, looking to find missing pieces, we have a checklist we go through. Number one, are there any right angles? In this case, that answer is no. There are no right angles. What's the second thing we look for? Do we have an angle and opposite side? In this one, do we have an angle on the opposite side? No. This one we do. So that would mean for this one we can use what? Law of sines. If we don't have, like over here where we don't have the side in the opposite angle, that means we're going to use law of cosines. So we just as well start off over here where we're going to have to use the law of cosines. Now, I purposely did not label any of these so that we could go through and label them however we want to. I like to label the angle that's between my two sides as angle C, because that hits our law of cosine formula a little bit simpler. So now remember, the law of cosines is C squared equals A squared plus B squared minus 2AB cosine of C. So to find side C here, it's going to be the square root of 30 squared plus 14 squared minus 2 times 30 times 14 times the cosine of 32 degrees. Just catch all that? Does that look familiar? So I'm going to punch at my calculator. Second square root. Second square root. 30 squared plus 14 squared minus 2 times 30 times 14 times the cosine of 32. We get 19.59 feet. So this is 19.59 feet. Anybody already have that? Okay. Now, to find angles A and B. I've got all three sides now. I need to find angles A and B. Which one do I want to find first? And there is a right answer here.
The big one.
Nope. Always want to find the smaller one first, because the big one could be obtuse. Now, the way this picture is drawn, it looks like it's obviously obtuse. But we always want to find the smaller one first, just in case. Remember we talked about if it's at like 96, 97 degrees, it's really hard. Is that 96 degrees or is it 84 degrees? Because the sine will be the same. But now we can use law of sines now that we have the 19.59. So it's 19.59 over the sine of the 32 degrees. It's the side in its opposite angle. Equals, I'm going to find angle B here, so I'm sine of B on bottom. What goes on top? Its opposite side would be 14. So we are going to cross multiply and divide. Sine of 32 times 14 divided by 19.59. 0.3787. Of course, that is the sine of B, so B is the inverse sine of that. 22.25 degrees. And now to find A, we will subtract from 180. 125.75 degrees. Correct? Anybody have that whole problem right before I showed it to you? So going over to this other one. Here we do have a side in its opposite angle, or an angle in its opposite side. So we've got the 17 over the sine of 41. That equals 26 over the sine of, we haven't labeled anything yet, so let me put labels in here. Let's call it A, B, C, little a, little b, little c. So that's going to be 26 over the sine of B. Here we are going to have to trust the picture. Remember we said whenever the opposite side is shorter than the second side, there's a chance that we could have an obtuse angle. Now there's another case, we could have all acute angles, but there's a third case where it might not be long enough to make a triangle too. But this one's drawn out, so we're assuming it makes a triangle. But here we also have to assume, because of the way it's drawn, that B is obtuse. So we're going to cross multiply and divide to find the sine of B. So sine of 41 times 26 divided by 17. Hopefully this comes out to be less than 1, and it does not. It is 1.003, which tells us what? It's not a triangle. This angle, this 17 here is too short to reach back. Remember, sine can never be greater than 1. So the fact that sine is greater than 1 is a bad thing. It tells us this does not make a triangle. So let's redraw it, making it work this time. So this is still 41 degrees. We're going to call this 21 feet and this over here 14 feet. So now we're going to have 14 over the sine of 41 degrees equals 21 over the sine of, that's angle C there. So we'll cross multiply and divide to find the sine of C. So sine of 41 times 21 divided by 14. 0.9841. So to find C, we're going to do an inverse sine of that. Second sine, second answer. 79.77 degrees. Now, is that what C is? We're going to assume from the way that it's drawn that C is obtuse. So how do we find what C actually has to be? Yeah, 180 minus that is 100.23 degrees. Has to be the supplement of the angle we find. So that means that this one here is 38.77 degrees. And now we could use that to find the third side. 14 over the sine of 41 degrees would equal side little b over the sine of 38.77 degrees. So we cross multiply and divide to find b. 14 times sine 38.77 divided by sine 41. 13.36. How do you guys feel about these? Bless you. Feeling pretty good about them? Feeling really confused about them? Want a couple more examples to look at? Okay. Find the missing pieces on this one quick. Okay, so on this one, if we go through our little checklist, we don't have a right angle. Do we have a side in its opposite angle? No, we don't. So that means we are going to have to use law of cosines. So now that we have that information, I'm going to label it. This angle is going to become angle C, so this will be AB. So little a, little b, little c. So the formula, C is going to be the square root of 18 squared plus 32 squared minus 2 times 18 times 32 times the cosine of 23 degrees. So square root 18 squared plus 32 squared minus 2 times 18 times 32 times cosine 23. 16.96. Correct? Works. Now, which angle do I want to find first? A is the smaller one. That's the one I'd usually want to go for first. So I'm going to do the 16.96 over the sine of 23 degrees equals, what side am I going to use? I always start off using the smaller side, so 18, and that would be over the sine of A. So sine 23 times 18 divided by 16.96 will give us the sine of angle A. So do an inverse sine. 24.50 degrees. And then, of course, we add those up. That's what, 47. So this is 132.5 degrees. How many of you came up with those three pieces? Good deal. Bit confused, Drew. Find the missing sides of that triangle. Okay, so on this one, at first it appears as though we do not have a side in its opposite angle, but on closer inspection, what do you find? Yeah. Anytime we're given two angles, we can find the third. So we know this angle up here has to be 123 degrees because they add up to 180. So now this is just a law of sines problem. 30 over sine of 123 equals, I haven't labeled it yet, so let's do that. So that's going to equal little a over the sine of 31. Does it matter whether we do the smallest or biggest first here? No, because we have all the angles, so we don't, doesn't matter. The sides will work out. So we cross multiply and divide to get a. 30 times sine of 31 divided by sine of 123. Comes out to be 18.42. So A is 18.42 feet, and of course you can do the same for B. What'd you get for B? 33. It seems a little big. 1602 looks better. How did I know 1602 is better? Because this is the smallest angle. That better be the smallest side opposite it. Well, let's give this a shot. So we've still got 30 over the sine of 123. That's going to equal B over the sine of 26. So sine 123 times Oops, that's wrong. 30 times sine of 26 divided by sine of 123. 15.68. What do you guys think? Good stuff? Well, that's good because... Yes, you do. So, questions arise. Where would we use all this stuff on a job site? Well, believe it or not, I use it way more than you would think, but obviously math comes easy for me, so I find it in places you might not. One place that it has been used, obviously when you get to surveying, next spring when you guys take your job site layout, site surveying class, this stuff does come up quite a bit. One application where I have used it, let's say you have a hill or some other sort of obstacle that's in your way, and you need to measure the distance between 2 points. That might be a lake, like I said, it might be a hill or whatever. What we can do is this. We can measure back to a common point, and we can go back to that theodolus that we talked about before to find the angle in between. Let's say we measure this to be 180 feet, and this we measure to be 205 feet. And we find this angle here to be 46 degrees. I want to now find the distance between those 2 points. Do I have a right angle? Not that I know of, no. Do I have an angle on its opposite side? No. So we're looking at law of cosines here. So this side over here, I'm just going to call it x. I want you guys to start getting used to not always having everything nice and neatly ABC, okay? But we know that that side is going to equal the square root of this side squared plus this side squared minus 2 times the 180 times 205 times the cosine of the angle in between them, which is the 46 degrees. Now, if you have to go through and label this as angle C and then angles A and B and whatever, go ahead. But like I said, I want you to start seeing these triangles not as letters, but just as the side opposite our angle and the sides adjacent to the angle and so on. So, $152.18. So it's 152 feet. I'm going to subtract 152 times 12 to make the remainder inches. That's 2. Subtract the 2 times 16ths. 2.8 is 3/16. Now, realistically, what I just did there is unrealistic because the error in any slight error in your angle over those distances is probably going to be more than a few 16ths difference on that opposite side, but just practice to restore it to feet, inches, and 16ths. Let's say that we have an existing roof here that looks like this brown triangle. And this is an old house, an old ridge beam and rafter house where they just set the ridge beam and put the rafters on there and they don't have a common slope to it. So the slope of this existing roof is uncertain. We could find it, but we don't want to at this point. And what we're going to add on to it here, our addition here, we are going to add on, well, let's take that back. Let's go back and give that a slope. let's say this one is actually a 7/12 slope on the existing. We're going to come out away from the house 20 feet. And we are going to do this at a 4/12 slope. Because that's what's going to make the peaks match up here. What I want to know, how long is this rafter going to have to be to go that distance? I'm going to argue that I know this angle. Do I know that? How do I know that angle? Because the slope. We have the slope of that means that the bottom corner of this is going to have a ratio of 4 inches of rise to 12 inches of run. So that angle here is simply going to be the inverse tangent of 4/12, the opposite side over the adjacent side. The inverse tangent of the slope is always going to be that called the heel angle, which should be 18.43. And there it is, 18.43 degrees. So now how do I find this angle? Inverse tangent of 7/12. $30.26 degrees. Now that's not really the angle I want. I want this one, which is going to be, you got it, 180 minus 30.26, or 149.74 degrees, which means this one up here can be found to be how much? 11.83, I believe. Does that look right? So now to find this side here, which was our x, it's going to be 20 over the sine of 11.83 degrees equals x over the sine of 149.74. So this would be 20 times sine 149.74 divided by sine 11.83. 49.16. So again, that's 49 feet. Subtract the 49 times 12. 1.93 is going to be 1 and 15/16 inches. What do you think? Good stuff? Well, there's good news. The good news is we are not going to learn any more trig concepts for the rest of the semester. Two pieces of bad news. One piece of bad news is everything we learn for the rest of the semester is just going to be a way of applying stuff we already know. And the other piece of bad news is this concludes Unit 3 of the semester, which means you're going to get a test to work on now and take home with you.